Good morning, good afternoon, or good evening. Welcome back to the channel. In today's video, I'd like to talk about configuration groups workflow inside of Cisco SD-WAN Manager. And we're gonna cater this video to a pretty common deployment within the SD-WAN fabric, which would be two routers at a branch site with different ISPs for connectivity. So again, it's not uncommon to have redundancy at your branch sites, and it doesn't have to be hard to configure. So without any further ado, let me go ahead and hop right into it. So I'd like to just discuss the concept really quickly, and then we'll dive into the actual configuration workflow. So what we're going to look at today is, like I said, two routers that live at a branch site. So you've got router 1 and router 2, and then the idea is that you'll have ISP1 and ISP2, which in the example I'm going to do is internet, right? And then you'll have, maybe that's a switch stack that sits at your site where you can essentially wire down router 1 into maybe switch stack member 1, and then router 2 would come down and wire into, maybe switch stack number 2, member number 2, and give you some redundancy there. Now, the idea is that router 1 is going to have a connection to ISP1. That can be, broadband, it could be fiber, it could be whatever flavor of internet you want or get or is available at that particular site. Same thing for router 2, but the idea is again to have diverse providers so that if one goes down, you have a backup to another ISP. Now, this is fine the way it's drawn here, with the exception of, okay, well, if router 1 has a hardware problem, right, how does it reroute to router 2 to get out to the internet? So what we need to do is configure a cross link between router 1 and router 2. And what we're going to do with that cross link is we're going to use it to extend either ISP to the other router, and that's going to be done through what's called a TLOC extension. And you can have multiple links there. You can have and form like an ether channel, port channel. You can do that if you want redundancy. You can do whatever flavor of this, suits your needs. You can add links where you see fit. I'm going to keep this very simple and just have a single link between all the devices as we see here. Now, again, ISP1 is going to have a unique IP address. All right. And ISP2 is going to have, let me see if I remember what I did here. It was 100.2. Okay. So it's going to be some flavor of 100.2. And for router 1, this is going to be 100.1, some flavor there. And again, the idea is for router 1, he's going to create a sub interface. In this case, it's going to be .100. .100 is going to be used to advertise or extend the 100.network or any other subnet in that case. But the point is 100 is going to be labeled as biz internet. Okay. The ISP2 is going to be deemed public internet. So router 1 extends the biz internet over that .100 subinterface over to router 2. So now router 2 has the belief that the biz internet is directly connected to one of his interfaces, because for all intents and purposes it is at this point, right? Now for router 2, he's going to do the same thing, right, for public, but in that case it's going to just be a different subinterface. So in this case I'm going to use .200, and he'll advertise or extend the public internet out of that interface over to router 1. All right. So again, now if we have an issue with the router itself, a hardware problem, the switch will route to the other router, and it'll always have a path out to the internet regardless of the failure situation. It could be a hardware failure, it could be a fiber cut, could be whatever the case may be. The idea is that there's always a redundant path out to the internet. Now, you might be asking yourself one other question: how does the switch distinguish between router 1 and router 2? That's a great question. we're going to see in the configuration workflow that it will take care of that for us with a first hop redundancy protocol, in this case, VRRP, Virtual Router Redundancy Protocol. And you can define which router you want to be the primary or the active there. And that's how it's going to track which router is having issues, if any, and determine which virtual IP address to send the outbound traffic to. So again, we're going to see that all this is going to be taken care of for us via the configuration workflow, and it's a very simple and easy process. So let's go ahead and jump over to SD-WAN Manager at this point. Okay, so within SD-WAN Manager, let's go to Configuration WAN Edges just so I can show you what we have going on. So we can see Site 5 contains the 2 London routers, but if you notice, there's not any configuration group tied to those 2 routers. They've essentially just been basically onboarded with a base config. So let's go ahead and bring up the workflow. So we're going to go workflow library, and we're going to go ahead and the very first option, we're going to go ahead and start this flow. I'm going to go ahead and just call it branch dual router. And for the site type, you can see it's going to prompt us with a option for single router or dual router. Okay. So obviously we want to go ahead and say dual router. And as we make changes on the left, you can see the topology kind of dynamically changes based on the selections we're making. I'm going to go ahead and just hide this for the moment, and we'll view it when we're all done here. For site settings, I'm just going to go ahead and give it a super secure password of Cisco Bang23. And most of what we're going to be focused on is going to be for the WAN and LAN side. So for WAN interfaces, you can see it's asking us if it's a full mesh or a TLOC extension. We're doing the TLOC extension as we discussed earlier. So I'm going to leave that as is. I'm going to, basically the 2 transports we're dealing with are biz internet and public internet. So I'm going to make those selections. In my case, they're both statically assigned IP addresses. You do have the option to have DHCP from your service provider, which will make life even easier. In my case, I'm just doing it with a static, and I want to make sure that I'm transport sharing to the other device here. All right. If we show advanced, I'm going to leave these as is just to show you how simple this can be. So we're done with the WAN interfaces. Now for WAN routing, again, you have some options here. You can do BGP with your service provider. You can do OSPF. In some instances, that's a use case. In this lab, I'm just going to do simple static routing. And I need to create 2 routes, 2 quad 0 routes, because again, I have 2 service providers. So for the next hop, just for sanity's sake, I am going to change this variable name. So biz inet next hop. And then I'm going to go ahead and create a second static route. And I'm going to make this pub. Okay. And now finally for the LAN and service side, we're going to obviously leave VRRP checked off because we want to have that first hop redundancy protocol. And in my case, I'm just doing VLANs 10 and 99 in my topology. So for 99, I'm just going to call that guests. And for 10, I'm just going to call that corp users. I'm not doing any routing or anything special there. I'm just basically carving off the 2 VLANs, which will make it router on a stick. So I'm going to go ahead and hit next. And for dual router high availability, I am going to enable that. And as I made mention of, you can do a port channel between your devices. In my case, I'm just going to do a single link. Okay. Now, if I click back on the topology, what we can see is what we ended up with is Edge 1 gets connected to Biz Internet directly. Edge 2 gets directly connected to Pub Internet. We extend those two transits between the routers across the links, and then we have our high availability link that we just enabled as well. On the LAN side, we just have two segments, VLAN 10 and VLAN 99. So that all looks good. I'm going to go ahead and hit next, and I'm going to create the configuration group. Notice it's creating all the profiles. So again, this is the power of the workflow. It's basically going through and creating all the Lego building blocks for us to make our lives easier. I can associate devices now or later. I'm going to do that later for a few reasons. For my particular lab, I need to tell it to have domain lookup enabled. I need to enable DNS and tell my routers what the domain name server is, because I'm not doing DHCP, right? So for dual router, I'm going to go ahead and drop this down. I'm going to add a CLI add-on profile, and this is for my AKV so I don't lose access to the CLI. So that's done. Under system, I'm going to edit the global, and I'm going to enable domain lookup like I made mention of. And last but not least, under the transport profile, I need to tell it VPN 0 what my DNS server is. In my case, it is a IP address within my lab. So I'm going to go ahead and save that. Now we're ready to attach devices to this group. So I'm going to go ahead and say add devices, and I'm going to simply select both London routers and save that. And we're going to go ahead and deploy. So we're going to deploy the configs to both routers at the same time, because why not? So you can see I've got Edge device 1 selected. So everything we do right now is going to be affiliated with router 1. And once we're complete, we'll go ahead and do the same thing for router 2. So under the basic here, I'm not changing anything here. It's just inheriting the values that it already knows about. This is where we're going to change most of this, input most of the variables. So again, we're focused on router 1 here. So this is the biz next hop, which in my case is 100.1.5.5. This is the public next hop, which in my case is 100.2.5.6. Now remember, this is actually the IP address that is going to be on router 2, because we're going through router 2 to get to the public internet. It's not directly connected. Standalone interface, this is that high availability piece. So this is gig 2, which is the cross link between the two routers. Now for public internet shared TLOC, this is where the sub interfaces come into play. So for public, if you remember, I said we're going to use VLAN 200 or sub interface 200 there. And for my case, that is going to be this IP address, which if you look up here, it's the other end of that. So this is essentially a /30 that's going to be between the two routers. Okay. So biz internet shared interface, this is the .100 sub interface now. Again, /30 there. And this is essentially this needs to tell the router what's the TLOC interface that we're trying to extend. In this case, it's the biz internet, which is connected to gig 1. So we need to tell it that's the interface we're essentially extending over to router 2. We've got 3 more to do here. Biz internet TLOC now. So remember, our biz internet's connected to gig 1, so we just tell it gig 1 there. That IP address is 100.1.5.2. and that's a /30 going up to the service provider. So with that, we filled out all the variables for the WAN side for router 1. Now we just need to fill in the LAN side. So VLAN 10 is going to be 10.5 for site 5, 10 for VLAN 10, and .1 for the VIP. This is a /24 in my case. And then the actual IP address that will be on the router is going to be .2. So remember, this is not the shared IP address. This is the shared VIP that we entered for .1. And then the downlink to the switch is gig 3. And then we're going to say just router on a stick is going to be subinterface.10 there. Very similarly, we're going to do 10.5.99.1. That's going to be the VIP. It is also a /24. 10.5.99.2. And that is going to be 3.99. So with that, that's all of the router 1 variables. Let's go ahead and quickly do router 2. Gig 2 here. All right, biz internet shared TLOC. So this is sub interface 100. .5.6 here, that's a /30. Public internet TLOC. This is the gig 1 going up to the service provider. Which is a /30. Public internet shared. So this is the .200. .5.6, that's a /30. And again, gig 1 is the going up to the service provider. That's the interface we want to tell it to essentially extend over to router 2. And for LAN side, similarly, 10.5.10.1, again, that's the shared VIP between the routers, /24. And then in this case, I'm just going to make it .3. I made router 1.2. I'm making router 2.3, and the VIP is .1. And that interface is gig 3.10. For 99, the shared VIP is 99.1 /24, 99.3, and that is gig 2.99. All right. So at this point, we filled out all of our variables for both routers. We're going to go ahead and say next, and we're going to go ahead and deploy those configs. We can watch the status live, okay? So while that's running, I'm going to bring up Secure CRT, and I'm going to get logged into both London routers. Okay, refreshing the page, we can see that first router 1, actually router 2 is on top. Router 2 completed slightly faster than router 1, but overall they were both successful. So if we come back over to the command line of each router, all right, and what we should be able to do now is a show IP interface brief. So on router 1, we can see we've got the raw interface going up to the biz internet. We've got 2 sub interfaces. 100 is essentially extending the biz internet over to router 2. 200 is receiving the pub internet from router 2. And then we've got the 2 sub interfaces for our VRFs or VLANs 10 and 99. All right. Checking router 2, we should see a very similar config. So the raw interface 1 goes up to the public internet in this case, we've got, this is not correct. I think I typoed something. Let's go back here. I probably typoed the interface on the LAN side for router 2. So let's just check that really quickly. Yep, I sure did. So gig 3.99, not 2.99. So let's go ahead and correct that. So router 1 didn't do anything. It's just essentially redeploying. Okay, so router 2 just finished. Let's see if that fixed our problem here. Okay, that's better. So 2.99 is now deleted. We should see 3.10 and 99, which we do, and we see our sub interfaces for the cross-link between the two boxes. Okay, perfect. So now there's a few ways we can verify. So if we show VRRP on router 1, we can see that there's two instances of VRRP running for .10 and .99. We can see that router 1 is currently the master for both instances. If we go to router 2 and we show VRRP, we can see that there's likewise two instances, but in this case, it is the backup, which is perfect. That's what we had anticipated there. Now, there is a way to view that in the graphical interface as well. So if we come over to Monitor, Devices, and we're going to go ahead and select London CEO1, and we're going to go to Real Time, and for device options, we're going to go ahead and type VRRP, and we should see a summary of the VRRP configuration. So you can see that router 1 is in fact the master, and it gives us the versioning, the group IDs, and all of that. So we can do the same thing for London 02, and we should see that it is in fact the backup, which we see here. So a couple ways to kind of verify that. So now that all the configuration's in place, let's go ahead and have a little fun here. So I've got a couple other sites living in the SD-WAN fabric. We've got San Jose and Research Triangle Park, which are already onboarded, and they have a device running respectively for each inside of VLAN or VRF10. So we should have reachability from London to San Jose and RTP for that matter. And you notice that all the boxes are 10.101. The only thing I change is the second octet respective of the site ID. So let's do some pings. So I'm going to hop over to, this is the host living in London that is hanging off of VLAN 10. Its IP address is 10.5.10.101. So I should be able to ping 10.5.10.1, which is my default gateway. That's the VRRP VIP, which you can see I can certainly ping that. Now I should be able to ping 10.3.10.101. So that's the device in San Jose, and then I should be able to ping 10.4, which is the device in RTP. So if I hit the up arrow and I ping 10.4, I have reachability there as well. Okay, so we've got reachability over the SD-WAN fabric. And if we wanted to see that from the routing table perspective, if I come back to London and I do a show IP route for VRF10, we see that we've got a couple OMP routes for 10.3 and 10.4. So that's perfect. That's exactly what we want to see. So let's go ahead and do a couple things. I'm gonna fire up that ping to 10.3.10.101, and I'm just gonna let it run here. We're gonna come back to the topology. Let's see if I can make this a split screen here. So essentially right now we're pinging from this device down here up to this device across the SD-WAN fabric. Now we didn't do a trace route. We don't really know exactly which transports we're using here, and it doesn't really matter for the time being. But we do know that CEO1 is the VRRP master, okay? So that means that from this device, we're going through the switch. We know we're directly going to that device here. So what I'm going to do is I'm going to click this is the biz internet link. I'm going to go ahead and I'm going to disconnect that. And as I disconnect that, we should see on London 01 and London 02, we should see some messages come across here. So on London 1, we can see that gig 1 has now changed state to down, okay? And on London 2, we can also see that its biz internet is now down, because remember, we extended that through a TLOC extension. But if we come back to the London device, you can see the pings are still running. We did not lose any connectivity there. So life is good. Come back to the topology. I'm going to go ahead and reinstate that link. And we should see some console messages that come back. We see the link has now come back up. So this signified fiber cut, flap, whatever you might, whatever you want to call it. But we had an issue with the biz internet in London. We've just restored all that connectivity. Life is good. Pings are still flowing. Let's go back to the topology and let's go ahead and disconnect the link between the switch and the router. So let's see what mayhem this causes. So we can see ping stopped momentarily. We can see that on router 1's perspective, we lost the downlink to the switch. It looks like the VRRP triggered a change there. We can see that on router 2, it has now become the VRRP master, which is to be expected. We can see pings are now flowing again, so we've just rerouted around that failure as well. So you can see basically, with the configuration workflow that Catalyst SD-WAN Manager provides, it really gives us all the bits and pieces that we need to ensure that we're configuring a branch location that has full redundancy, utilizing all of its links efficiently and effectively. So let's just do one more thing here too, just for clarity. So I'm going to break this ping and I'm just going to do a trace route. So remember, all the connectivity is been restored. Everything's the way we expected. Everything's in an up state as we speak. We can see the first hop in the trace is 10.5.10.2, which if you recall, that's the router 1 IP address because we made it the VRRP master. From there, it looks like it's actually going through 10.2, which is interesting, right? So it's actually sending it over the public internet, which is again, it's kind of interesting, right? We didn't tune anything, and that might be as a result of us disconnecting that link. So 100.2 is pub. So let's go ahead and down the pub link. So let's go ahead and disconnect this. We'll wait for the console messages. Oh, I'm sorry. I apologize. I jumped the gun here. So this is it's 100.2, which is public, but the third octet's a 3. That's site 3. So it's coming into site 3 over the public internet. That's all that matters. That's all that means. So again, so if we wanted to cause a failure there, what I really need to do is down that link. So let's reinstate this link. And this is gig 1, which is biz. This is gig 2, which is pub. So I'm going to disconnect this link on site 3. And now if we do that trace route again, I'm hoping we see 101 3, 2. Yep, there we go. So again, just to kind of demonstrate, once you have this topology built out, you can start to downlinks and see. I mean, it's very, very quick convergence, very effective. Like I said, pretty cool stuff here. So I'll end there. Hopefully this was meaningful. Hopefully you got something out of this. Drop me a like, feel free to subscribe, ask me any questions, but I look forward to seeing you guys in future videos. Thanks and take care.